Hello everybody and welcome to Blockchain Expert. In this video, I'll be walking you through a project that utilizes Chainlink. Now this project is going to show you how to use VRF, which is Verifiable Random Function. This is something we can use from Chainlink to get a random number into our smart contract and to make sure it is verifiably random. I'm also going to be showing you how to use Chainlink automation. Now, this allows you to automatically call a smart contract function, say every 10 minutes or 20 minutes, or when a specific kind of logic has changed. So you'll see what I mean by that in a second, but essentially you can write a function on your smart contract, and when that function returns true, you then will automatically call another function. This is actually a very cool project, and the way we're going to implement this is by writing two contracts. We're going to have a fortune teller contract and a fortune seeker contract. Now, the fortune teller contract is going to get a random number from Chainlink using the VRF service. It's then going to use that random number to generate a fortune. So we'll have kind of a list of strings, and it will randomly pick one of those strings, which will be your fortune. Now, again, we're using VRF to do this, so I'll show you how to use the Chainlink Oracle. Then we're going to create another smart contract, which is Fortune Seeker. Now, this contract is where we're going to implement Chainlink automation. So this contract is going to be automated such that Chainlink will automatically call a function on it, which will check if the fortune has changed in the fortune teller contract. So we kind of have two different pieces here. We have one piece where we're using random numbers, another piece where we're using the automation. Then we're going to connect those together and show you or kind of introduce you to the power of oracles and what you can do with a network like Chainlink. Now, I'm not going to lie to you here. This is a complicated project. There's a lot of stuff that's going on. And to make life easier for you, what we've done is set up a template folder that already has a lot of the complex configuration and automated tests written for you. Now, I'm going to walk through all of this code and make sure that you understand it. But I just want to be clear that if we were to try to write all of this from scratch, this would take a very long time. Now, one other thing that I want to mention here is that this project was actually provided to Blockchain Expert by Chainlink engineers. So we've been teaming up with them for parts of this course. We're very thankful to have them helping us here, and they've been providing projects like this to us. So they actually wrote this project from scratch, gave it to us, and now we're going to kind of explain it and show you how to actually utilize it. So hopefully that makes a bit of sense, but I just want to kind of say thank you to the Chainlink engineers and make it clear that this was designed and developed by Chainlink. I here am simply the instructor and kind of just walking you through the project they already provided to me. Okay, with that said, I apologize for the long intro. Let's get into this video though. The first thing we're going to do, as I was saying, is download a template folder. Now you can do this from the Blockchain Expert website. Obviously, you can also download the complete solution, or you can go to GitHub and view all of the code there. However, this template folder contains some but not all of the finished code, and it's just enough to kind of get us up and running without having to write a ton of code that is pretty hard to follow along. So please download the template folder. You're going to have to extract it because it's a zip folder, and then open it up here. So I have template open. Now inside of here, you're going to see contracts. Right now we have some mocks, which I'll discuss in a minute. We're going to have to add some contracts here. Then we have tasks, tests, our gitignore file, which has a bunch of different files that we don't want to push to a GitHub repository. We have our prettier ignore, which just means the prettier extension in VS Code is going to ignore these files when we're doing kind of checks on it in terms of formatting and whatnot. We then have prettier RC. Again, this is kind of some settings for the prettier extension. If you're not using that, don't worry about it. We have hardhat.config.js. Typically, this is a very small file, but in this case, we have a bunch of custom configuration that I will walk you through. We then have package.json. This contains all of our dependencies already set up for us. And then we have testnets.config.js, which is actually setting up some kind of variables that we need access to when we're going to be deploying our different smart contracts. Okay, so the first thing we're going to do here is we're going to make sure we're in the template directory, and we're just going to install all of the dependencies. Now, the way we can do that is just by typing npm I. This is going to read through package.json, get all of the dependencies, and then download them for us. This is going to take a few minutes for you. For me, I already have them all installed in my node modules folder. Now, what we're going to be doing here for this video is we're going to be using a live test network. Now, we need to do this to interact with Chainlink because we need the Chainlink Oracle network to be able to actually communicate with our smart contract. So we can't do all of this on our local network. In fact, there is a way to do it, but it's not kind of in a real environment. So we need to actually connect to an Ethereum test network, get some free Ether, and then utilize that as well as Chainlink. So the first thing we're going to do here is we're actually going to open up our browser. So let me just open up a new browser tab here, and we're going to connect to something known as the Avalanche, Fuji network. Now, this is a special test network that the Chainlink engineers have told me about that is fairly fast and reliable and should work for you. You can use other networks as well, but I'm going to recommend you follow along with this one because that's what this video is going to do. So how do we do that? Well, we can open up MetaMask, and we can connect to the Fuji network. And in fact, you can see I'm already connected here. Now, obviously, I need to walk you through these steps. So we're going to go to Add Network, and it's going to bring us to this page here. Now, we do have the option to connect directly to the Avalanche Network C chain, but that is not what we want. We want the Fuji network. So we need to find the information for that and then add the network manually. So let me pop up the page that has this network information, and then I will be right back. All right, so I've just popped up this page here that says how to connect to the Fuji test network. Notice this is from the Avalanche website, which is what provides this test network for us. And this is the information that we need. So feel free to pause the video and then you can kind of copy all of this, or you can just look up how to connect to the Fuji test network, and you should be able to find this page relatively easily on Google. You also could just pause and type this link out. So I'm going to copy all of this stuff. So let me get the network URL. I'm going to paste that here. I'm going to get the test network names, put that here. The chain ID, take that. Okay, make sure all of these are the same. Our currency symbol is AVAX, and then we're going to have our testnet.snowtrace.io, which is kind of like your Etherscan, URL. Okay, now it's giving us some error here. Don't worry about that. Going to click on Save, and there you go. We've just added this test network. So now you can change that by just clicking on it in the Networks tab, and I'll close this one here. Okay, now you'll notice I already have some AVAX because I've been experimenting this with this before, but I'm going to show you how we get access to that. So again, pause the video if you need to so you can copy this information. Otherwise, we're going to close this page, and now we're going to find a faucet that will give us some tokens. So the URL for this is going to be https:// and then this is going to be faucet.avax.network. Okay, so this is a testnet faucet, as it says, and what we need to do is change our chain to the Fuji C chain, which is the one that we are on, and then we need to paste the address in here that we want to receive 2 AVAX tokens to. Now, you can only do this every 24 hours, so just keep that in mind. Don't send it to the wrong address. Now, the way you can find the address is you can open up MetaMask like we have here. You can go to one of your accounts. I'm just using account 1, and then copy the address, as many of you probably know. So if I paste that in here, and then I request this, so unfortunately I'm not able to get this to work because I've already transferred myself those tokens. However, that's fine. I have enough for what we need to do in this video, so that's okay. And you will have enough if you have your 2 AVAX here. So again, go to this faucet, put in your wallet address for the correct network, obviously, which is the Fuji network, and then you should be sent 2 of these tokens. Okay, perfect. So now that we have access to that, the next thing that we need to do is get access to some Chainlink. However, before we do that, we need to actually add Chainlink to our MetaMask. So there is another website. I apologize for all the links here, but this is what it is. It is docs.chain.link/resources/link token contracts. Now, obviously, what you can also do and what I did to find this page is I just Googled how to add Chainlink to MetaMask. I opened up the first link here, and then it said, see the link token contracts page to find the addresses. So I clicked on that, and then that's exactly the page that's right here. Okay, they're the same page. So what I'm going to do now is scroll down, and I'm going to find Avalanche, but I'm looking for the Fuji test network. And then what I can do is just click this handy button here that says add to wallet, and that's going to pop up MetaMask and automatically add the Chainlink to my wallet. So I'm going to go add token. Now, notice I already had some Chainlink, again, because I've been messing with this before the video, but I'm going to show you now how we get access to Chainlink tokens. All right, so now that we have that added to MetaMask, the way that we get some free Chainlink is we go to faucets.chain.link, okay? And that's going to allow us to connect to MetaMask. You can see I'm already connected here. If you're not, then press on the button, connect to MetaMask, make sure the network is Avalanche Fuji. I don't know why I keep mispronouncing that. Make sure you have the correct wallet address here, and then you can press for the CAPTCHA thing. So we'll go through all of the grapes here. Okay. And then we can get 20 testnet link. So it should just send it to our wallet. Okay, so once that is done, I'll be back, and then we will continue. Okay, so it looks like this has completed. So what I can do now is go to MetaMask to verify this. And if I look at my account and I go to assets, I see that I have 35 Chainlink. I just got 20 more. I don't know what the limit is for getting Chainlink here, but I have done this a few times and it seemed to work. So there you go. Also, there's a link to the Fuji faucet right here. Okay. Now we have our Chainlink, we are set up on the Fuji network, and now what we need to do is close all of this. Let me just actually leave MetaMask open and go into some of our configuration files and start looking at how we actually connect to this from Hardhat. Okay, so what we're going to do is just kind of start going through some of the files here in some more depth, and I'm going to explain to you some more advanced configuration options for Hardhat and why we kind of have all of these files here. So again, we have our contracts, we have tasks, tests, and then everything else. So I'm going to start in my hardhat.config.js, which is a file we haven't really looked at up until now. Now, notice here that what we do right away is we import 2 of these tasks. Now, these tasks are exactly what they say. They are the deploy scripts. So we need a script for deploying our fortune teller contract, which again, we haven't written yet, and then our fortune seeker contract. Now, what we get, or what we start by getting, is the environment variable for the Fuji RPC URL. Now, notice here that we have a default option, which is actually what the correct one is, so we're not going to have to fill this out. But we're looking for the URL of the network that we would want to deploy our contracts to. Then we have our private key. Now, this is going to be the private key of our Ethereum account. Now, obviously, you don't want to share this private key with anyone, hence why we're putting it in an environment variable, and I'll show you how we write the correct environment variables such that this script is going to work for us. Anyways, for now, imagine that we're getting the RPC URL of the network we want to connect to, as well as the private key of the account we want to use for our deployer. Next, what we're doing is getting our Blockchain Explorer API key. Now, we're going to get this in a second, but this is going to allow us to essentially verify transactions kind of in an automated way. We're then getting access to the report gas environment variable, which is telling us if we should make a report of all of the gas that was spent for the different deployment transactions that we're going to do. Okay, next we create a task. Now this is something that we haven't talked about yet, but something that you can do with Hardhat. So since we have this require statement here, we have access to task, and we can essentially create a Hardhat task. Now that task is something like this, npx Hardhat, and then whatever the task is. So when I write task and then I have deploy seeker, that means that now I can go and write deploy seeker. So this is very similar to something like test, right? This is a built-in task. Or compile, this is a Hardhat task. Or deploy, those are all tasks that you can use with Hardhat. So here we have a custom task that we're writing, which is deploy seeker. And this just gives us a description of what this task is. Next, we add a parameter. Now, this tells us that when we want to deploy the seeker contract using this task, we need to pass a fortune teller address. Okay, so that's the parameter that we're specifying here. Then we have set action. Set action means, okay, what happens when we actually have this task typed in? We have an async function. We accept our arguments and then our Hardhat. And what we do is deploy the fortune seeker contract, which is a function that we'll look at in a second. Then we're just doing a catch here in case anything goes wrong. We're going to print out what the error is. Now, exact same thing for deploying the fortune teller. Again, I don't need to kind of bore you by writing this manually. You can see how this works. We can set up these 2 custom tasks to make our life easier to automatically deploy this code. Perfect. Okay, now we continue to some more configuration options. So we have Solidity, which is just specifying different compiler versions we have access to or that we should be using. We have our default network, which is the Hardhat network, so the localhost network that we've used many times now. And then we have custom networks in here. Now, when you specify custom networks, what this allows you to do is when you write npx Hardhat deploy, you can go -- network, and then you can specify one of the networks that you've put here. So we could do localhost, we could do Hardhat, or we could do Fuji. Now, Fuji here, we're going to use our Fuji RPC URL, and then we're going to specify our private key as one of the accounts that we have access to. Now, the chain ID is going to be different because that's the chain ID for the Fuji test network. So hopefully this makes a little bit of sense, but this is how we set up another test network within the Hardhat configuration. Now, since we're not using our localhost node, we need to actually have our own private key here, which we specify, as well as the RPC URL for this network and the chain ID. Then this is, again, going to automatically push to that test network for us. Okay, next we have Etherscan. Now, this is going to be our block explorer key. I don't think we actually specify this. Let me just check here. Block explorer key. Okay, so that's right here. And sorry, this is going to give us access to the testnet explorer, kind of the Ethereum Explorer, whatever you want to call it, blockchain Explorer, so that we can verify that different transactions or deployments have actually gone through. You'll see how that works later on when we actually use this deployment script. That's why we have this here. Now, Gas Reporter, this is an option that we have in Hardhat that allows us to generate kind of a output file telling us how much gas was used. And you can see that we're specifying the currency is USD. So it's going to generate a gas report.txt for us whenever we do a deployment transaction, etc. Okay, next we have Contract Sizer. I'm not really going to discuss this very much, so don't worry about it for now. And then we're going to have Paths. And then Mocha. Now, this is just for our tests. We're just setting a timeout here for running all of the tests because they could take a fair amount of time. All right. If you want more information about this, feel free to look up the Hardhat documentation. Again, I'm not going to get into that right now. Okay, so that is the hardhat.config.js. Does look a little bit confusing, but hopefully it's understandable what everything is doing in here and kind of how that works. Next, we have our testnet.config.js. Now, inside of here, what we're doing is essentially specifying some variables that we're going to have access to, but only when we deploy to this test network. Now, we're going to use those variables from our tasks here. So for deploy fortune seeker and deploy fortune teller. And all of this stuff is going to make sense in a minute because we'll kind of be able to change this and fill it up. The information we have other than the subscription ID should be correct, but this is something we need related to Chainlink. And again, I can't really discuss it too much right now, but you can see something like the link token address is going to be the address for the smart contract that represents Chainlink on whatever test network we're using. In this case, this is the address for the Fuji test network. And then again, coordinator address, that's another contract address that we need to specify based on the specific network. Okay, so that's testnets.config.js. And then I think I already discussed getignore and prettier and all of that. Okay. Now we want to look at our tasks. So we have deploy fortune teller. This is the first one we want to look at because this is the first contract we're going to write. Okay, so notice we're loading in our testnet configuration, right? So from testnet config, so that then we get access to the variables that we defined inside of there. Then we're getting some variables here from Hardhat, and we're setting up a few other variables that we're going to need, okay? VRF coordinator, subscription ID, VRF coordinator address. All of this will make a little bit more sense later once we start actually looking at this. And then we have the chain ID that we're going to be using. Now, the first thing we want to figure out is, are we deploying this to a local network or not? Now, if we're deploying this to our local network, that means we can't actually use kind of the proper real Chainlink Oracle network. That's because the Chainlink Oracle network is only interacting with things over the internet, right? It's not going to interact with our local network. So in that case, we need to use something known as a mock. Now, a mock, if you're familiar with testing, is essentially faking what a real kind of resource would be. So in the case of Chainlink, we would actually be using a real oracle, but if we're on our local network, we can't do that. So we're going to mock what that oracle would be so that everything works like it would in a real environment, but kind of faked in a sense. So I know that's a bit confusing, but that's kind of the best that I can explain it. So that's why we're checking, okay, are we on a local network? Now, if we are, we need to do all of this. And really what all of this is doing is setting up the mock of Chainlink. I don't want to get into this too much because we're not really going to use this in this video, but just understand that when you're doing automated testing or when you're trying to deploy only to a local network rather than a real test network, there is some things like mocks that you do need to consider if you were in a larger development project or kind of team environment, etc. So here we have to specify the base fee, the gas price for Chainlink, the fund amount, all of this. We have to set up a mock, okay, so we get the mock contract, then we need to deploy the mock contract, okay, we need to get the address, we need to send a transaction, and then we're actually going to fund the coordinator mock, okay? Again, seems a bit weird. I know this probably makes no sense right now, but this is all needs to be set up for Chainlink to work on your local network. Now, if we're not on the local network, as you can see right here, then we don't need to do that. Instead, what we need to do is we need to get the subscription ID, which is actually going to be on the real Chainlink Oracle network, as well as the coordinator address. Again, that's coming from our testnet.config.js, and then we can use that when we are deploying our smart contract. Okay, now if we don't have either of these values, we get an error. That makes sense. Okay, and then we're going to say we're deploying it to whatever network we're on. Now, this is kind of starting the actual real deployment stuff, okay, not related to Chainlink. Here, what we're doing is we're getting the contract, as we already know, and then we're deploying it. And for this contract, we're going to require the subscription ID and the VRF coordinator address. Again, I'm going to talk about what all of these things are. Don't worry about them too much. Now, wait for block confirmations. This is just waiting for, in this case, if we're on a local network 1, if we're not on a local network 3, confirmations or new blocks to be added. The reason we're doing that is to make sure this transaction is valid before we actually spit out and say, hey, all of this was successful. Okay, then we have a wait, fortune teller contract deploy transaction wait. So we're just waiting for this number of confirmations. Then we're going to log that we deployed this. And then here, if we're on a live test network, verify the fortune teller contract. We're going to verify this using our Etherscan API key, as you can see right here, userconfig.etherscan. If we are on a localhost network, then we're going to add a consumer. This is something that we're going to do manually ourselves, but since we're setting up a mock for Chainlink on our localhost network, we would need to do this here. Okay, again, apologize that a lot of this is not fully making sense yet. It will as we actually start kind of looking at Chainlink and setting up these contracts, but I do just need to walk through this first so that you don't have a ton of code that makes zero sense. All right, now we have deploy fortune seeker. Now for deploying the fortune seeker, we're doing very similar things to what we did for deploying the fortune teller. Now recall that when we use the fortune seeker, what we're doing is essentially calling a function on it every X seconds. In this case, we're specifying 10 seconds. That's going to check if we need to look for a new fortune on the fortune teller contract. So to test the fortune seeker contract, we actually need to have the fortune teller contract deployed. And that's why it's asking us for the fortune teller contract address here when we deploy the fortune seeker. Same thing, we're waiting for our block confirmations, and then we're going to verify that this was correct. Now, in terms of setting up mocks here for Chainlink, we're not doing that in this example just because we don't really need it for this style of contract. Again, you'll see why once we actually start writing it. For now, though, this is the task, okay? There you go. We have gone through the tasks. We will revisit those after we write our smart contracts, which is what we're going to start doing now. So first of all, in contracts, notice we have mocks, okay? Mocks, we have a file, and all we're doing is importing a smart contract, which is going to be used as our mock, okay? Again, don't worry about it too much, but that's why we have that there. Now, what I'm going to do is create a new file, and this is going to be our fortune, if we can spell this correct, fortune teller .sol. Okay, so let's start writing fortune teller. So first, let's write our pragma line. We're going to say pragma solidity, and then for the compiler version, we're going to go 0.8.7. Okay, next we're going to import some Chainlink contracts. Now, these are coming from, if we go to package.json, Chainlink/contracts. Okay, since we have this imported, we have access to them from node modules. So I'm going to say import, and this is going to be at Chainlink/contracts/src/v0.8/ and first we're going to access some interfaces. So we're looking at /interfaces. Then this is going to be the VRF coordinator. And then this is the v2 interface.sol. I know this is a lot, but that's the first one that we need. Don't worry about the red highlight. We do have access to this. It's just not able to pick it up for some reason. Next, we're going to have at Chainlink/contracts/src/v0.8. And then this time, we're going to directly access the VRF consumer base v2.sol. Let's spell v2 correctly. Okay, next, we're going to import. We can copy kind of the first part of this. So let's put this here. All right, and then we're going to access the confirmed owner.sol contract. Okay, perfect. So if you, for some reason, have some issue with these imports, you can reference the GitHub and just copy them. In fact, let me fix this because I realized there's a mistake right there. Okay, so we're importing all of the contracts that we need. Now, one thing to kind of talk about here in terms of how this is going to work is essentially we're going to create a contract. Inside of this contract, we're going to write something that allows us to kind of talk to Chainlink and say, hey, we want to get a random number. When we do that, Chainlink is then going to take that request for a random number, go to the Oracle network, and ask for a random number. It's then going to send that random number back to us. Now, before it does that, it's going to send it to a contract. This contract is going to verify that the number actually is random using some cryptographic properties that we don't need to discuss. And then we're essentially going to get the random number from that smart contract. Once we have that random number, we can then use it in our contract however we please. So our contract is referred to as a consumer of what's known as a subscription. And this is essentially the Chainlink kind of model, if you want to call it, the Chainlink contract that's going to be sending us our random number. So we are going to Chainlink saying, hey, give us a random number. We need to be a consumer of the subscription that we're using to get this random number. And then it can send that random number back to us by calling a function on our smart contract known as a callback function, where we then will register the random number and do something with that. Again, as I continue to write this, it will continue to kind of crystallize, but I just wanted to give you some idea of what it is that we're doing here and why we're importing some of these functions, hence kind of the names of them. All right, so now we're going to define an interface that we're going to use in a minute. This is going to be fortune, if we can spell this correctly, and then seeker. Now, the reason we're starting this with is because that's kind of, what would you call this? One of the conventions for an interface, just to start it with the letter I. And then we're going to write inside of here, function, and then this is going to be fulfill fortune, okay? And this is going to take string memory underscore fortune, and that's going to be, well, whatever the fortune is, and then we're going to say external. Again, you'll see why we need that in a second. Just write it out for now. Okay, now we're going to write our contract. So we're going to say contract having issue spelling fortune, but we're going to say fortune teller, and then we're going to inherit from the VRF, we can spell this correct, consumer, and then base v2. We're also going to inherit from the confirmed owner. Okay, so those are the two contracts that we imported, right? VRF coordinator, sorry, not interface, but base v2, and then the confirmed owner. All right, now that we've done that, let's start writing some events as well as some storage variables that we need. Okay, so first event is going to be request sent. And this is going to take a uint of the request ID, and then a uint, we're going to make this a 32 of the number of words that we are requesting. Now, a word is just going to be a random number, okay? So whenever you hear me say words here, that's really referring to an instance of a random number. Next, I'm going to say event, and then this is request fulfilled, and this is going to take in a uint request ID, as well as a uint array of random words. Now, in this case, we're only going to be requesting one random word at a time, but it is possible to request multiple. So we're kind of writing this in a more dynamic way such that later you could change it and you could request multiple random words at once. Okay. Next, we need a list of fortunes. Now, I'm going to copy this in. I'm not going to bore you by writing it, but we're just going to have a string array here. We could put this in bytes. It would be more efficient, but for testing purposes, it's fine to be a string. And we're just going to have a bunch of different fortunes here that we can randomly select from. So feel free to read these out, copy them if you want, or you can just put your own, or you can only have one or two, completely up to you. Okay, next, we're going to have a string, and we're going to say that this is public so that anyone can view it. And then this is going to be the last returned, and then fortune, like so. Now let's make sure this is capital. Now the reason we want this is so that we can track whatever the last returned fortune was and give that to our fortune seeker contract whenever it calls into this contract. Okay, so we're going to keep track of that. Next, we're going to have a struct called request sent. Sorry, not request sent. This is going to be request status. Okay. Inside of here, we're going to say bool fulfilled. We're going to have bool exists, and then we're going to have uint array of random words. All right, so whenever we send a request for random words, we're going to create one of these request status structs. We're going to store this obviously in some kind of mapping, which you'll see in a second, and then we're going to update the status to be fulfilled whenever we actually receive our random word, and then we'll put that random word inside of this random words array. Hopefully that makes a bit of sense, but we are essentially requesting a random word. Okay, we got to wait for Chainlink to give that to us. Once it gives that to us, we update this information, then we're good to go. All right, next we're going to create a mapping. We're going to say mapping, uint, and then this is going to go to our request status, so that we have the IDs kind of mapping up with our statuses. And we're going to make this public. We're going to say s underscore requests. We're just going to preface this with S because later we're going to have to use a request variable. So this is just storage requests, right? Okay. Next, we're going to say our VRF, and then this is going to be the coordinator, and then V2 interface. And then we're going to say in all capitals that this is our coordinator. Okay, we're going to talk about this in a second, but this is essentially going to be the smart contract that allows us to coordinate the random numbers. So we have this coordinator contract that essentially will make sure that the random numbers that are coming to our smart contract are verifiably random. You can read more about this in the Chainlink documentation, but there is a cryptographic proof that is submitted with all random numbers. The coordinator is essentially what coordinates or looks at this proof, makes sure it's correct, and allows us to actually get access to this random number. Okay, so we have VRF coordinator, V2 interface of coordinator, like so. All right, next we have a few more state variables. We're going to say uint, and then this is going to be our S underscore subscription ID. Okay, we're going to specify that in the constructor, which we'll write in a minute. The subscription ID is going to reference the Chainlink subscription. And again, this is kind of what we call it in Chainlink, to access a random number. Next, we're going to say uint. We're going to make this an array. This is going to be public. And then we're going to say this is the request IDs. And we'll just make this equal to an empty array for right now. And actually, I don't even think I need to specify this. I can just leave it like that. Reason for that being that we want to keep track of all of the different requests that we have generated. So we're going to put that in this array. Next, we're going to have a uint public, and this is going to be the last request ID, just so we have a variable that can quickly tell us what the last request ID was so that we can then look that up. All right. Next, we're going to have bytes 32. This is going to be called a key hash. For now, I'm going to make this equal to an empty string, but we're going to fill that in a minute with some Chainlink information. Okay. Next, we're going to go uint. This is going to be 32. We're going to say this is the callback gas limit is equal to, and then this is going to be 100,000. Okay. Next, we're going to have uint request confirmations. And we're going to make this equal to 1. We could make this equal to more than 1 if we wanted to. Again, the confirmations is the number of blocks that have been validated since the block that contains your transaction. And the reason you would have this is so that you're not going to start using any random number or value submitted here until it has a certain number of confirmations. However, for dev, 1 is totally fine. And then next, we're going to have uint numwords is equal to 1. Now, just to quickly touch on this callback gas limit here, this is something we're going to use to make sure that the callback into our smart contract when we receive a random word does not cost too much gas, because that's going to be using actually Chainlink funds of ours, which we'll look at in a few minutes. So we're just kind of setting a maximum, right? So we're setting it at 100,000. It can be difficult to determine what this value should be, but it should be the maximum amount of gas that you could potentially use from the callback function, which again, we need to talk about. I'm sorry, there's a lot of stuff we need to discuss. This is a little bit complicated, but just kind of bear with me here. It will all make sense. Okay, now that we have all of our storage variables defined, we're going to create a constructor. Now, what we need to know here when we create this contract is we need to know what our subscription ID is, which again is kind of how we're going to get our random number from Chainlink. And then we need to know what the coordinator address is. So look here, we have our VRF coordinator. We need to know what that is because we're going to use that coordinator contract as a part of this process. So we're going to say constructor, and we're going to say uint 64, and then this is going to be our subscription ID. We're then going to take address, and this is going to be VRF, and then coordinator like that. Okay, so now that we've done that, we need to initialize both of our base contracts here. So VRF consumer base and confirmed owner. So what we're going to do is write VRF consumer base v2, and then we're going to pass to this the VRF coordinator because that's what it requires. And then we're going to say confirmed owner, and we're going to pass to confirmed owner our message.sender. All right, now the confirmed owner is essentially just going to do everything that we've done manually ourselves previously, where we've specified who the owner of the contract was, and then we've had that kind of modifier only owner. So this just provides it for us so that we don't have to actually write it in this contract. Okay, now we're going to set our coordinator equal to the VRF coordinator. And actually, sorry, this is going to be the VRF coordinator v2 interface. And then we're going to wrap our VRF coordinator, sorry, in that such that we know that it adheres to this interface. Okay, next we're going to say s underscore subscription ID, which is our storage variable, is equal to the subscription ID. Again, that's why we put the prefix s here. All right, that is our constructor and all of our storage variables. Now, let's talk again quickly about kind of the process here. So we're going to have a function, and I'll write it now, and it's going to be request random words. Okay, this is going to be external. Only the owner can call this, and this is going to return a uint of request ID. All right, so what we're going to do is we're going to call this function. When we call this function, we're going to use this coordinator contract, which is essentially our way of communicating with Chainlink to request random words. There's a few things we need to pass when we do this, which we'll talk about in a minute. Now, once we request that, we're going to mark, okay, we just made a request. And we are waiting for this request to be fulfilled and to give us a random word. So that's kind of, function one. We request our random words. Next, we have another function. And this is going to be fulfill random words. Now, this is what's referred to as a callback function. So this function is going to take a uint underscore request ID. And it's also going to take a uint array in memory of our underscore random words. Now, this is going to be internal, and this is going to override one of the functions from our VRF consumer base, okay? So this is a function that we have to write for our VRF consumer base, and the reason this is internal is because the consumer base contract is going to handle receiving the words, and then it's going to pass those words to this function. So this is where we essentially handle the callback of actually receiving the random words or the random numbers into our smart contract. Hopefully that makes sense. But this is where you request it, and then this is where it's going to be received. And this will be received asynchronously, right? So it's going to take a few seconds to generate the random words. Once they're ready, it's going to call this function, and then we can handle everything we need to inside of this function. All right, so these are the two, let's call it kind of meaty functions or most complicated parts. Once we have the random words, then we can do whatever we want with them. So this is really kind of your setup, right? You have your two functions, request random words. You can call this anything you want, by the way. And then your fulfill random words, but it needs to be called exactly this because we are overriding that from the VRF consumer base v2 contract. Okay, let's go into request random words. So when we request random words, we're going to say that our request ID is equal to our coordinator. Now, notice that what I'm actually doing here, since I've labeled my return value, is I'm just specifying the request ID that I want to return in this variable, in this return variable. Hopefully that makes sense. Okay, so request ID is equal to coordinator dot, and then this is request random words. Okay. Now, when we request the random words, we need to pass the key hash, the s underscore subscription ID, the request confirmations. This is the number of confirmations we're going to wait for, the callback gas limit, and then the number of words that we want to actually request here, right? So I think that's fairly straightforward. The only thing I haven't explained is the key hash. Again, don't worry about that too much. It's just based on the specific network that we're using to actually request these random words, all right? Now, the subscription ID is referencing, again, the Chainlink subscription that we're using. And the reason we need this is because we need to provide Chainlink with funds so that it actually has the ability to do this, right? We have to pay for this. It's not free. So we're going to provide Chainlink funds to our subscription. And then that's going to allow us to actually be calling this fulfill random words function, okay? Hence why we have like a callback gas limit. We'll talk about that later once we get to that step, but that's why we have some of this information. Okay, so we use the coordinator contract, request our random words. By the way, this coordinator contract is the same for all of the smart contracts that are on one of these test networks. So every test network will have a different coordinator address, but there's just one coordinator contract for our random words. Hopefully that makes a little bit of sense, but you would use the same coordinator in multiple smart contracts. Okay, next, we're going to have s underscore requests at our request ID. Remember, this is our mapping, is equal to our request status. And then inside of request status, we'll initialize the values that we need. So we're going to say the random words is equal to a new uint, and then we're just going to initialize this with a length of 0, just so that we do have an array here. And sorry, this needs to be a colon, not equal sign, and that needs to be a comma. Next, we're going to have exists. This is true. And then we're going to have fulfilled, and this is false. Okay, so we're kind of initializing this request status struct and then storing that associated with its ID. Next, we're going to say request IDs dot push. And then we're going to push our request ID here. And then we're going to say the last request ID is equal to the request ID. And then we're going to emit our request sent event, just in case we need to use that from some kind of front end. And we're going to pass here the request ID as well as the number of words that we requested. Then we're going to say return the request ID. Okay, so there you go. That is our request random words function. You can kind of write this however you want. All you really need is this to request it. All right, now that we have this, we're going to write our fulfill random words function. Again, the reason that Chainlink or the coordinator contract knows to call this is because we are a consumer contract, which we've inherited from right here. So that's why you need to write this function exactly as I have, okay? So we have fulfill random words. Inside of here, we're going to require, first of all, that s underscore requests at underscore request ID exists. So that you can't call this function if the request ID has not yet been created. And then we're going to have as our error request not found. Okay. Next, if this is not the case, right? So if the require statement is kind of true and we get past this, then we're going to say s requests. This is going to be at our request ID dot fulfilled is equal to true. And then we're going to set what the random words are. So we're going to say s requests at request ID dot random words is equal to the underscore random words. And then lastly, we can emit the request fulfilled with the request ID and the random words. Okay, that's all we need for fulfill random words. So now that we have fulfill random words and request random words, we have what we need to actually be generating a random number and to be receiving that inside of our smart contract. The next step here is to actually write some logic related to our fortune teller, right? So returning a random fortune, viewing information about a current request, etc. So we're going to say function, and then this is going to be get request, and then status like this. We're going to take a uint underscore request ID, and then this is going to be an external view that returns, and we're going to return bool fulfilled, and then uint array memory, and we'll label this as random words. So I'm just using the labeled returns. You don't have to, but I think it's more clear for this example. All right, so when we do get request status, first of all, we need to require that this request actually exists. So we're going to say s underscore request at underscore request ID dot exists. And then otherwise, we're going to say request not found. Okay, and then we're going to say request status, and then this is going to be memory request is equal to s requests, and then this is at underscore request ID. Okay, let's put our equal sign here, and then we are going to return, and then this is going to be the request dot fulfilled and the request dot and then the random words. Okay. There you go. That's all we need for getting information about the current request status. Now that we have that, we're going to write a function called seek fortune. Now, this function is going to be used by our fortune seeker contract. So it's going to seem a little bit out of place right now, but I'll explain how it works. So we're saying function seek fortune external payable. So we're actually going to require funds be sent to this smart contract to receive a fortune. Now, what's going to happen is our other smart contract, fortune seeker, is going to call into this contract. It's going to call this function right here. And what this function is going to do is it's going to return whatever the current fortune is. However, the way it's going to return this is by calling a function on the contract that called this function. So this is referred to as a callback. The reason we're doing that is because that's how we need to return this information. We can't just have a regular return statement. And you'll kind of see what I mean and kind of how we've set this up. So we're going to say require, and we're going to say message.value is greater than or equal to 0.001 ether. And then this is going to say insufficient payment to the fortune teller. Now, keep in mind, there's all kinds of other ways to do this, but this is just kind of the example we wanted to show you here. Essentially, what we're doing is we're requiring a certain amount of ether to be sent such that when we call back the callback function, we have enough money in gas to do that. So we're making sure that you're funding our contract before we call a callback function, because if we try to call a callback function and we have no funds, then that's going to break, right? We're going to have a revert. So what we're going to do now is we're also going to require that the last request ID does not equal 0. And otherwise, we're going to say no request fulfilled yet. So this way, we're not going to let them call this function if we haven't had any random words yet, if we haven't generated a fortune. Okay. Now what we're going to do is we're going to say string memory fortune. And then this is going to be equal to the get fortune function, which we need to write in a second. We're then going to say I fortune seeker. Remember, that's the interface that we wrote right here. And we're going to create this. So we're going to say I fortune seeker. We're going to call this seeker is equal to I fortune seeker. And we're going to wrap the message.sender. So that's the reason why we wrote this interface, so that now I can view the message.sender address as a fortune seeker contract. And I know that the fortune seeker contract has what function? Well, the fulfill fortune function. I'm going to fulfill that fortune with the fortune that I have right here. So this is kind of what I mean by the callback. We're calling into now whatever called us, because we're viewing it as a fortune seeker and passing to it the fortune information. All right, now let's write our get function. Let's write our get fortune function. So we're going to say function get fortune public, and then this is going to be returns, and we're going to return a string memory. Okay, now inside of here, we're going to say string memory fortune is equal to fortunes, and then we're going to access a specific index. So we're going to say s request at the last request ID dot random words at the 0th index modulus the fortunes dot length. Now let me just explain what's going on here, and then actually let's return our fortune. Okay, so what we're doing here is we're using the random number that we last generated. So we're saying s request at last request ID. I think that's straightforward. And then random words at the 0th index. Now that's because we know we're going to have exactly one random word. That's how we set up this contract. If we had multiple, there'd be other things we'd do here, right? But we access the random number or random word. We then divide that by the length. Now keep in mind, when I say word, it is a number, okay? So we can use this modulus operator. So when I modulus this by fortunes.length, that guarantees that I'm going to get an index that's within the bounds of my fortunes array. So I'll always get a valid fortune, and it will be completely random because the return value here is based on a randomly generated value that we know is verifiably random. Okay, hopefully that is making a bit of sense. I also just want to mark here the last return fortune is equal to fortune, and that's one of the reasons I didn't make this a view function, because we are actually accessing or modifying the state. All right, we just need 2 more functions here, and then we are done. We're going to say function get contract balance, okay? And we're going to say this is a public view that returns a uint, and we're going to return address of this dot balance, just so we can easily access that. And then we're going to say function withdraw balance. And the reason for this is so that we don't just lock Ethereum in this contract, and that the owner of this contract, after all of these seek fortune functions have been called, can take any remaining balance after the gas fees have been paid. So we're going to say public payable. Only the owner can call this. Okay. And then we're going to say bool sent is equal to message.sender call, and then this is going to be value address this dot balance, and then we're going to put our empty string. Okay, let me just add the other quotation mark here. And we're going to say require sent, and then we're going to say failed to send ether in withdraw. Okay, and then one thing here, I'm just going to make sure this is payable. So I'm going to wrap payable message.sender like that. Okay, so I think that is good. And those are all of the functions that we need here for this smart contract. So let's just quickly go through it, and then I will actually deploy this and show you how we set it up with Chainlink, and then we can actually start using it and seeing how we generate our random number. So we have our iFortune Seeker interface. Okay, we've gone through that. We have our 2 events. We have all of our fortunes. You can write whatever ones you want. We're storing the last fortune that we returned, so that we always have access to that. We have our request status that tells us if it's fulfilled, if it exists, and what the random words were that were returned to this request. We have our mapping, which is associating IDs with their statuses. And we then have our coordinator contract, which is what we need to use to actually request a random number. Okay, next we have our subscription ID. This is essentially how we determine what Chainlink balance we should be using to pay for all of these random number generations. We then have our request IDs. The last requested ID, the key hash, which again, we don't need to talk about too much, just related to Chainlink, callback guess limit, request confirmations, number of words, and then our constructor. For a constructor, we need the subscription ID and the coordinator address. This varies based on the network that we're working on, hence why we can't hard code this in. We then are going to call the constructor for our base contract, so VRF consumer base v2 with the coordinator, and then confirmed owner with the message.sender to set that. We then set the coordinator and the subscription ID. Then we move on to request random words. This is what we call only as the owner to essentially get a new random number and change the fortune, okay? So we use coordinator.request random words, pass all the information that we need. Then we create a status. We then push our request ID into the array. We make sure that we mark our last status, right? Our last request ID, sorry. And then we emit this event and return the request ID. Next, we have fulfill random words. Notice this is the override. This is required when we are using this VRF base contract. And what we're doing first is just requiring that the request ID does actually exist so that we first called request random words. We then are going to mark this request ID as fulfilled. We're going to set the random words and we're going to emit this event. Next, we have the get request status. Okay, just giving us information about a specific request ID. Seeking fortune. This is an external function that is meant to be called by a fortune seeker, right? Hence why we have the fortune seeker that we're using here, and we're going to return the fortune in a callback like so. Okay, so seeker.fulfill fortune. Next, we have get fortune. Get fortune is a public function anyone can call that's going to give us what the current fortune is based on the last requested random number. Then we have get contract balance. That's straightforward, and withdrawing the balance, same thing. Okay, we have now finished the smart contract. It is time to deploy it and to test it. So let's do that now. All right, so first thing we need to do here before we deploy is we actually need to open up a Chrome tab, and we're going to go to a link here that's going to allow us to configure our Chainlink subscription. So we're going to go to the following, vrf.chain.link/Fuji, okay? Because this is the network that we're working on. So let's go to that. It's going to bring us through this page. Let me just make this full screen. First of all, connect your wallet, okay? Now, once you do that, what we're going to do is we're going to look for the key hash, the link token, and the VRF coordinator. Now, notice if we go back to hard hat here, let me just kind of make this half our screen, that the link token, VRF coordinator, and key hash are all things that we need. So if we go to testnet.config.js, right, we have our coordinator address and the link token as well as our subscription ID. Now, these are correct because when I did this using Chainlink. However, if you don't have these for some reason, or if you're working on a different network, then you need to swap these, okay? So copy these, paste that in, same thing, okay? And then we'll get to the subscription ID in a second. Now, we're going to go to Fortune Teller, and we're going to hard code in here the key hash, okay? So we're going to copy the key hash and just paste it, and it actually doesn't need to be inside of a string. Just put it as a regular bytes value, okay? So we copy the key hash inside. Okay, that's step one. Next thing we need to do is create a subscription. So we're going to go create subscription. For the subscription address, we're going to use our connected MetaMask account, okay? So we're going to go create subscription, and it's going to use MetaMask to do this. So let's go ahead and do that. And we need to use a bit of Ether for the gas fee for that, right? Okay, so this transaction will take a second. And once it's finished, then what we're going to be doing is, I guess, kind of setting up this subscription and adding our contract as a consumer. Okay, so now it says add funds. So what we need to do here is add funds to the subscription. It gives you a detail here, right? Add funds to your subscription. Your subscription is only billed after your contract receives a random value, and you will never be billed more than the maximum price you specify. You can withdraw funds at any time. Now, we do this using the link tokens that we got. So in this case, I'm going to add 5 link. Use a very small amount of link each time we request a random token, and you can see how much later. Okay, so we're going to go add funds. All right. Same thing here. We have to pay for this. So let's go ahead and do that. And notice the Chainlink here is an ERC20 token on the Fuji network, and there would be a Chainlink token on all of the different test networks or main Ethereum network that you're using. Okay, now we're going to go to add consumers. Now, this is where we need the address of our contract. Now, I'm just going to click on I'll do this later because we haven't yet deployed. Okay, so this should bring me back to the main page. Now, notice that we have a subscription with ID 508. So we're going to copy that ID. We're going to go to a testnet. We're going to paste that in here. So now we have our coordinator address, the link token address, and the subscription ID, and we'll be able to actually deploy our contract from Hardhat. So the first way we can do it is from Hardhat. However, we also probably want to do this from Remix, and I'll show you how we connect to that in a second so that we can actually test this, because we're not going to write a front end or like a user interface for this project. We're just kind of getting the random number and everything set up. So, of course, if we wanted to deploy this, we can use the task that we wrote. So let's have a look at that. If we go to our hardhatconfig.js, we have our deploy teller. And the way we run this is npx hardhat, and then this is deploy teller. Okay, so we can go ahead and run that. And we got an issue. Let's see what the problem is. It says artifact for contract not found. Okay, so the way we're going to fix this is we're going to say npx hardhat compile, just to compile all of our contracts and get our necessary artifacts. And we got an issue. Okay, so this is actually good. This means we need to fix something in our code. So let's go here to fortune teller. And it's telling us on line 92 we have an error. Let's go to 92, and it's saying, what is the issue? Did we mean to use underscore random words? And that is correct. We did mean to use that. Okay, so let's try to compile again, see if we get any other errors. Okay, we got an issue with request ID. Again, same thing. We meant to use underscore request ID. Okay, let's run this again. See if we get any other errors. Number of words. Okay, of course, that makes sense. So let's go here. Okay, so the issue here, actually, sorry for the cut, is that we are trying to convert a uint 256 value to uint 32. So that means in our request sent event, we have int 32 before our number of words. Let's find that here. We have a uint 256 when this actually needs to be uint 32. So change that to a 32. And now we should be good if we compile again. And we got another issue, request confirmations, invalid type for argument of function call, invalid implicit conversion from uint 256 to uint 16. Okay, so that's going to be on line 70 right here. So for request confirmations, let's go and change this to a uint 16. My apologies, guys. I must have just been messing up some of the types here when I was copying it in. Okay, let's run this again, and we'll see if we have any other errors. S subscription ID, okay, same thing. Invalid type conversion from uint 256 to uint 64. So let's go to our variable here for subscription ID, and we're going to make this 64. Okay, I have a feeling we're going to get some more errors, but let's keep running and see which ones we can fix. All right, looks good. We have just compiled the contract. All right, guys, so my apologies about all of those mistakes, but that is what happens when you work on a project. Hopefully, you guys were able to fix all of those along with me. Again, if you weren't, all of this code will be available from GitHub or from the download link, so you can reference that in case you're getting any errors. You can also just read the error message you're getting and fix it like I just did. Okay, now that we have compiled this, we should be able to deploy it. So let's go npx hardhat deploy teller and see if it works this time. All right, so there you go. We have just deployed. Now, this has deployed to our local network, okay, to the Hardhat network. Now, we don't have the Hardhat node running, so we're not kind of viewing any of this right now, but that's what it did, okay? It just deployed to our Hardhat network. So what we want to do instead is want to deploy to the Fuji network. So we do npm hardhat deploy teller, and then -- network, and then Fuji, and then we would be able to deploy there. However, you're going to notice that we did not yet create our environment variable file for all of the variables we need here when we're deploying to Fuji. So we need our Fuji RPC URL, our private key, if we're reporting gas, and all of that. So let's add that in now. So we're going to go to template, and we're going to create a .env file. Inside .env, we need a few variables. So I'm going to copy these. Actually, we don't need the RPC URL because we already have the default here, but we're going to take private key. I'm going to show you how we get this in a second, by the way. We're going to go to Fuji Snow Trace API key. Again, I'll show you how we get that. And then I'm going to go to report gas. Okay, and let's put that in here. So report gas, I'll make this equal to true. And then we need our private key and our Fuji Snow Trace API key. So for the Fuji Snow Trace API key, we're going to go to the website here. I'm just going to pull it up on another tab, which is Fuji Snow Trace. All right, so let me just bring up a website here. My apologies. We're going to go to snowtrace.io/APIs. And here we are going to sign in or create an account to get access to an API token so we can use that to verify our contracts. So I'm going to sign into my account here, and then I will be right back. All right, so I've signed into my account here, and you can see that I have API keys. Now I have an API key that I can just copy and use because I've already generated one, or you can go to add, and you can create a new API key and give it a name. Obviously, you don't want to share this with people, but for this tutorial, it's fine. Okay, so that's as easy as it is. You go to snowtrace.io / in this case, it's my API key. It's going to ask you to sign in if you haven't already. Create a new account if you haven't. Sign into that account, and then go to API keys, generate one. And then we're going to go here and we're going to paste that API key for this environment variable. Lastly, we need our private key. Now, the way we access our private key is through MetaMask. So we're going to go to MetaMask. We're going to go to our account. Okay, so we're on the account that we want. We're going to go to the 3 dots. We're going to go to account details. And then you're going to click on export private key. Now, I'm not going to click this in front of you because I don't want to share it with you. What you're going to do is you're going to export this, you're going to copy it, and you're going to paste it where private key is, okay? No quotation marks or anything, just paste it right there to the right side of the equal sign. Let me go ahead and do that, and then I'll be right back. All right, so I have pasted my API key inside of the .env file. Obviously, I don't want to open that because I don't want to leak that key to you. You don't want to share that with anyone, and make sure you keep it in an environment variable file and not inside of any of your source code. Do not share your private key with anyone, otherwise they will get all of your funds, whether it's on a test network, whether it's on a real network, doesn't matter. They will rip all of them from your account. So please keep your private key safe. Anyways, it's in there now. So now what we can do if we'd like is we can deploy this to the Fuji network. Now, if we deploy this to the Fuji network, then what's going to happen is it will give us the contract address. It will verify that it was deployed. It will give us some gas information, etc. So feel free to do this if you want. However, I'm not going to do this because it makes it a little bit more difficult to actually test our contract. So what I'm going to do instead is connect to Remix, and then I'm going to deploy through Remix. Now, again, keep in mind that if you're deploying in this method, you need your coordinator address and your subscription ID. These need to be valid, otherwise your contract is not going to work, okay? And there's another step as well that we'll go through, but I'm just trying to walk you through all of the different methods because there's a bunch that you can do here. So you can deploy in this way, or what I'm going to recommend is we deploy through Remix. So the way to do this through Remix, I did show this in one of the Web3 Tools videos, is to go to the Remix extension, which you should have installed in Visual Studio Code, and to start the Remix client. So I'm going to do this. It's going to take a second. Okay, now it tells me to go to this website. So I'm going to go to remix.ethereum.org. And now, let me just close this. I'm going to go and connect to localhost. Okay, I'm going to click connect. That's fine. And this should now connect me to my local workspace where I have my template folder. Perfect. That's exactly what we want. Now what we need to do is compile our contract, and then we can deploy it. So I'm going to go to contracts, fortune teller. Now that I'm there, I'm going to go here to compile, and I'm going to compile my fortune teller contract. Okay, so that is now compiled. Now I'm going to go to here, deploy and run transactions. And now, let's just make sure we have this page open because we're going to need this in a second. Let's go full screen. Let's go deploy. And we want our subscription ID. In my case, it's 508. For you, it's going to be different. And we want our VRF coordinator. So for our VRF coordinator, we can get that from a few places. We can also get it from here. So I'm going to go Avalanche Fuji here. I'm going to copy the VRF coordinator. Notice my subscriptions are here, okay? I'm going to go back to Remix. I'm going to paste that in. Okay, so now that I have this information, I actually almost forgot, but I'm going to change this so that we're using our MetaMask. Okay, we need to make sure we're connected to MetaMask, otherwise this isn't going to work. And then I'm going to click on transact. It's going to pop up MetaMask, and I'm going to pay my fee. I'm going to deploy this, and then in a second, once it's done, we'll have deployed contracts. Okay, there we go. Now we can start using this. So for example, I can look at the owner. I can look at the last returned fortune, which is nothing. The last request ID, which is 0 because we haven't requested anything. We can get the contract balance, etc. Okay. So what we want to do if we want to start using this is use request random words. So let's request random words, and it gives us an issue. It says this transaction will likely fail. Now, the reason this is going to fail is because we've not yet added this contract as a consumer on our VRF subscription, okay? So the way we do this is we copy our contract address, we go to VRF, and we click on our subscription. So I'm going to go to 508. Inside of here, I'm now going to go to add consumer. So we need to be added as a consumer. So I'm going to paste this address inside of here. And you can have multiple consumers, by the way. Otherwise, this isn't going to work. So we're going to pay our fee to add this as a consumer. And now we will be able to actually consume a random number. Okay, let's give it a second here to finish. And then we can test it out and see if it's actually being received. Okay, so let me close this because that is done now. Notice we have 1 consumer, 0 fulfillment. All right, that's fine. Let's go back to remix. And now let's try to call this function. So we're going to say request random words. Notice this time we don't get that error because we are a consumer. And now I'm going to confirm. And now let's look at last request ID. Okay, so I just had to wait a second here for this transaction to go through. Now we can see the last request ID has been updated. And if I copy this and I paste this here, now that we see that it has been fulfilled. Okay, so fulfilled is true. And we have our random word. Now, if I had done this a little bit sooner, then you would have seen that it wasn't fulfilled and we were still waiting for this to come in. Anyways, it's fulfilled. Now, what I can call is get fortune. So notice if I look at my last returned fortune, I'm not getting anything yet, and that's because I haven't generated one. I need to generate one using get fortune, so I'm going to call get fortune here. This is a state changing operation, hence the transaction. Okay, let's confirm. And now, if I go last returned fortune, we should see in a second here that we get a fortune. So all your hard work will pay off soon. There you go. We have just generated a random number using Chainlink VRF, got that inside of our smart contract, and then use that to generate a random fortune. There you go. You have officially integrated with Chainlink and used a decentralized Oracle network. So this is just kind of part 1 of this project. We're going to continue now and write another contract called Fortune Seeker. It's going to utilize this contract, and I'm going to show you about Chainlink automation. However, at this point, take a quick breather, grab some water, maybe have some lunch or some food, because this obviously was a lot of work. I know this was complicated, but now you're really going to see the power of combining these 2 different tools and how, okay, yeah, we just got random numbers. That's already pretty cool. We can do quite a bit with that. But now we add this automation piece in. We have these 2 contracts interacting with each other, and hopefully this will give you a really good sense of the type of applications you can build using decentralized oracles. So that's really, again, all I need to test for now. What we're going to do is go back to Visual Studio Code, start writing our Fortune Seeker contract, and then we'll do the same thing, deploy that, set up the automation, etc. So actually, one thing I quickly wanted to show you before I do that is when I go back to Chainlink VRF here and I look at my subscription, so 508, you can see that we have 1 fulfillment, right? And if we click in to our subscription, how do I view this in more detail? Not sure if I can do that. Right here, okay? We can see that we have an address, we have the fulfillment, the total amount of link that was spent for that fulfillment, etc. Okay, it gives us kind of the history of what happened here, success, the current balance we have afterwards, and then events, all right? So there you go. Hopefully that makes a bit of sense, but that is how the Chainlink subscription works. Now, as I was saying, let's go back to VS Code. All right, so let's create another contract. Let's call this one Fortune Seeker.sol. Now here, we're going to say pragma, solidity, and then this is going to be, again, the hat, and then 0.8.7. Okay, we're going to say import, and then this is going to be at Chainlink /contracts /src /v 0.8 / and then this is going to be automation compatible .sol. Okay, now that we've done that, we're going to say interface, and then this is going to be fortune teller. Notice not seeker this time, teller. And then here we're going to say function seek fortune, which is a function we do have on our fortune teller, and this is external payable. Okay. Now we're going to write our contract. So contract fortune seeker is automation compatible. And sorry, this is going to say automation compatible interface. Now, just a note I need to make here is that when we import automation compatible, this is actually going to import two things for us. It's going to import the interface. It's also going to import our automation base, which we don't actually need to use right now. Anyways, just so you know, like the reason I'm using the interface here is because it is actually imported by this import statement. I know, a little bit strange, but we need the automation compatible interface here. Okay, so we're going to write two events. I'm going to say in sufficient balance, or insufficient funds, sorry, not balance. And we'll say that this is going to be uint balance. And then I'll say event, and this will say received funding. And then this will be a uint amount like so. And now we're going to write a few different public variables that we need. So again, just to clarify what we're doing here, we're going to write fortune seeker. Fortune seeker is going to be automated, meaning it's going to kind of automatically call into our fortune teller looking for if the fortune has been updated. That's the idea. So we need to set this up using kind of chain link automation. So we have two specific functions we need to write that adhere to this interface, and then we can write whatever logic we want inside of those. So first, let's say address, public owner. So we're not going to use the owner contract this time. We'll just kind of do it ourselves. We're going to say address, public, fortune teller. We need to know that address so that we can call into it. And then we'll say string public fortune. Okay, so the last fortune that we got. Then we're going to say uint public immutable and then interval. Okay, just meaning it cannot be changed. And then we're going to say uint public, and then this is going to be last timestamp. And you'll see what we need then in a second, but it's the last timestamp that we updated the fortune at, or not quite, but that we did a certain operation at. Okay, next we're going to make a modifier. We're going to call this only owner, and we're going to require that the owner is equal to the message.sender. Otherwise, we're going to say caller is not the owner. Okay, and then we're going to put our underscore here to call the underlying function. Next, let's write our constructor. So constructor, we're going to take address underscore fortune teller, and then we're going to take our uint update interval, which is how often we want to update the fortune. Okay, then we're going to say our fortune teller is equal to the underscore fortune teller. We're going to say the last timestamp is equal to the block.timestamp. We're going to say the interval, interval is equal to the update interval. And then we're going to say the owner is equal to the message.sender. All right. Now, the two functions that we need to write here to adhere to this automation interface are check upkeep and perform upkeep. Now, the way this works, at least the way that we're going to be doing this, is we're going to make it so that the chain link kind of automation system is going to call a function. This function is called check upkeep. If this function returns true, it's going to tell Chainlink to call another function called perform upkeep. So essentially, we're doing automation based on logic. So whenever this check upkeep function returns true, based on the state changing, etc., then we call the perform upkeep function. Rather than doing this based on time, which is another option you have with the Chainlink automation system. You can instead do it every 30 seconds, every minute, every hour. We're not doing that. We're doing it based on kind of this check update function, okay, which you're going to see. So let's write this. I'm going to say function check and then upkeep, and make sure you write it exactly like this because we need to adhere to the interface. We're going to say bytes and then call data here as our parameter, and we don't actually need to put any name, okay? Then we're going to say that this is an external view override returns, and we're going to return the Boolean of upkeep needed, and then bytes memory, okay? Then what we're going to do here is say bool interval exceeded, is equal to the block.timestamp minus the last, and then timestamp like so, and then that this is greater than the interval. So I know this seems a little bit counterintuitive to what I was saying, but we're doing this using the logic approach, but the logic that we happen to implement is going to be based on time. So essentially, we're only going to call this perform upkeep function if the last time that we called the perform upkeep function is greater than whatever the interval is that we specify here, okay? Now, again, we could have done the same thing just using Chainlink's time system, but we're going to do the time implementation ourselves. Okay, next we're going to say bool sufficient balance is equal to, and that's going to be address this dot balance. And I'm going to make this greater than or equal to 1 ether. Okay, and then I'm going to say upkeep needed is equal to the interval exceeded and sufficient balance. Okay, and then we don't actually need to return anything because automatically we will return this variable because we named it here. Okay. All right, so I know this is a little bit confusing. I haven't explained all of this quite yet, but essentially, we're only going to allow this upkeep function, which is the next function we're going to write, to be called if we have at least 1 Ethereum in balance. The reason for that is we want to make sure that this contract has sufficient balance to pay what we need to pay to view the fortune, as well as all of the gas required in having a callback function called and all of this other kind of stuff, okay? So this is a lot of Ethereum. We don't need to make it this much, but just for simplicity for this example, we're going to require we have at least 1 Ethereum inside of this contract before it allows us to move further and actually kind of get the fortune, okay? So this is check upkeep. Next, we're going to write perform upkeep. Now, this is the function, again, that's going to be called by Chainlink that is going to actually, well, perform the upkeep. Pretty straightforward. In this case, it's going to get the fortune. So we're going to make sure this is an external override. Want to make sure it has exactly this. Again, we don't need to actually use this parameter, so we just specify the type, but we don't need to give it a name. Okay, so we have perform upkeep. Inside of here, we essentially need to do the exact same thing that we did here, just for good practice, to make sure that this function is not accidentally called or called by something other than the kind of Chainlink automation system. So I'm going to copy this line here, or these lines, paste them in, and I'll actually copy these as well, and I'm going to make this a Boolean. So I'm just going to put a require statement here as a guard clause, and I'm going to say require upkeep needed, sorry, and then I'm going to say upkeep conditions are not met. So again, it's the exact same thing that we had here. I'm just copying it in kind of as good practice inside of the perform upkeep. That's what you should do. All right, then I'm going to say last timestamp is equal to block.timestamp because now we're actually going to seek the fortune. I'm going to call the seek fortune function, which we're going to write on this contract. So it's a bit weird, but the seek contract function is going to be on this contract, but then we'll call the one on the fortune teller contract from this function. Okay. Before we do that, let's just write a few other functions it needs. So get contract balance, okay. And this will be a public view that returns a uint, and we can return address this dot balance. Then we can say function withdraw balance, because of course we don't want to lock up Ethereum. And this will be a public payable only owner function, okay? And then we're going to say bool, and then let's go here, bool send, all right? And then we're going to say payable is equal to payable message.sender, and then this is dot call. Then we're going to say value is equal address this dot balance, put our empty string, and then again require send, and then we'll say failed to send ether and withdraw. Okay, so just like we had for the other contract, that's fine. Now we are going to write seek fortune. So we're going to say function seek fortune. This is going to be public. Okay, so this just allows us to test this and to call it outside of just the Chainlink automation function calling it. I'm going to say if address this dot balance is less than 1 ether, Then what I'm going to do is emit the insufficient funds, and I'm going to say address this dot balance, okay? And then I'm going to call revert. I'm going to say not enough balance to call fortune teller. Let's end our string here. Okay, and that's what we need for the if statement. And then we're going to continue. We're going to say I fortune teller is equal to I fortune teller. We're going to wrap the fortune teller address. Okay, and then we're going to say teller dot seek fortune, and we need to pass to this some funds. So we're going to say value 0.001 ether, which is the required payment that we need to send. Okay, so just by the way, this is how you call a function while passing Ethereum. So we're calling an external function right on the teller, what do you call it, smart contract, and we're passing 0.01 ether, which is what's required. Just to verify here, if we go back to seek fortune, this is the function we're calling that requires this Ethereum. Okay, so we're wrapping the fortune teller address, which at this point is just a normal address, with iFortune teller, so we can then view it as a fortune teller contract. Boom, call fortune teller, and we are good. Now, the thing is, remember that when we call seek fortune, it's going to call fulfill fortune on our smart contract, this contract that called into this. So we now need to write that. So we're going to say function, and then this is going to be fulfill, and then fortune like so. We're going to say string memory underscore fortune. This is going to be external, and then we're just going to say that our fortune is equal to our underscore fortune. Perfect. Now, since this contract here is going to need to have funds, right? It needs to actually receive funds because we have this check where we need to have at least one Ethereum before we're able to perform the upkeep, then that means we need to write a receive function. So we're going to say receive external payable, and then we're going to emit in here receive funding. Let me just make sure that I'm spelling this correctly. I am not, so that's why I'm getting an error. Okay, so emit receive funding, and then this is going to be the message dot value. Okay, so that is going to complete this smart contract. So let's go through it. Okay, we have our interface for our fortune teller contract. That's what we need. We have fortune seeker is automation compatible interface. That means that we need to implement those functions, which we have. We have our two events, and we have all of our public values, or all of our, sorry, well, they all are public, but I mean storage variables. Then we have our modifier, like always, for only owner. We have our constructor, where we get the fortune teller contract, as well as the update interval. Then we have check upkeep and perform upkeep. These are the only two things we need for this to be automation compatible. Tell us, okay, should we do an upkeep? If this returns true, then we will perform the upkeep. However, again, we need to have at least one ether. Okay, so once we do that, we call seek fortune. We update the last timestamp to make sure we only do this every, X seconds or whatever the timestamp is. And then when we call seek fortune, we go here again, we do this kind of same check, and then we call seek fortune on the fortune teller contract. The fortune teller contract then calls back this fulfill fortune function, which then allows us to update our fortune here, and then we can view that from the public variable. Of course, we then have withdraw balance, get contract balance, and the receive function. Okay, that wraps up the fortune seeker contract. Now that we have done that, we need to set up the kind of automation event for fortune seeker. This is a little bit simpler than the kind of random number with fortune teller, but let me walk you through the steps. All right, so I've opened up Chrome, and the URL that we need to go to is https://automation.chain.link. Okay, now we actually need to go to /Fuji as well to make sure we're on that network. It says it's detecting our wallet, so let's make sure that we're connected. Okay, we're not, so let me connect my wallet here with MetaMask. Okay, let's connect this. That's fine, and now we are connected. Okay, now what we're going to do is we're going to register an upkeep. Okay, so let's go register new upkeep. And we have two options, time-based or custom logic. So as I was saying, we can do it based on time or custom. In this case, it's custom logic because we're calling that function, okay? Now, all this is requiring is our contract address. And then it's just automatically going to work because it knows, what do you call this here? that it needs to call this should upkeep or check upkeep function, as well as the do upkeep. I forget exactly what it's called, but you know what I'm saying here. If I go back, check upkeep and perform upkeep, okay? It knows to call those functions. So that means we need to deploy this. So I'm going to deploy this from Remix, okay? So I'm back in Remix here, and notice that I'm still connected to localhost. At least I believe I am. Yes, it looks like I am. Now I'm going to go to my fortune teller contract. Let's go contracts here. And sorry, not fortune teller, fortune seeker. Okay, my fortune seeker. I'm going to go here, and it says that we got an issue. It says undeclared identifier. Did you mean received funding? Yes, I meant received funding. So let's change this here to received funding. Okay, and then again, let's just fix this bug here. So that's going to say dot balance. And I think everything else is good. Okay, so let's compile this, fortune seeker. And now that it's compiled, we'll make sure we're connected to MetaMask, and we can deploy fortune seeker. Now, when we do that, we need the fortune teller address and the update interval. Now, unfortunately, my other deployed contract has gone away. So what we can do is just deploy our fortune teller contract again. Okay, so let's go here. Let's change this to fortune teller. So let's go and open up fortune teller. Okay, let's go and compile fortune teller. Okay, we'll go here, and we need the subscription ID and the coordinator. So that's going to be 508. And then we need to go back and find the coordinator. We can actually do that here from VS Code by going to testnet.config and grabbing the coordinator address. Okay, so now we're going to paste the coordinator in here. And again, let's make sure this is all good. All right, transact. Okay, we're going to transact this. Our deployed contract should be here in a second. Okay, very good. We need this address, so let's copy that. And now we're going to deploy our fortune seeker. So again, for our fortune seeker, no, not iFortune seeker, just fortune seeker, which seems to have disappeared. Okay, so let's go back here. Let's select fortune seeker. So fortune seeker here, compile fortune seeker. Apologize for all the steps, but you guys know what we need to do at this point. Let's go to fortune seeker, and let's paste our fortune teller address, and then the update interval. Let's just make this something like 15 seconds, okay? Now we're going to hit transact. Okay, and let us transact this. Perfect. So now that's going to be deployed, and then we should have a fortune teller and a fortune seeker. Now again, the fortune seeker is going to be calling into fortune teller, but that doesn't mean that it's going to be triggering fortune teller to be generating a new fortune. So we still need to generate the fortune from fortune teller manually. We could automate that as well, but we're not going to do that in this video. So I'm going to request random words here, and I'm getting an error. The reason I'm getting an error, let me get out of this here, is because I need to add this as a consumer contract, because notice that we've deployed another consumer, right? So let me go here. Okay. Oops. And let me just go back to my subscription. All right. So I've just punched in the URL again, vrf.chain.link/Fuji. Let's go here. Again, apologize for all the steps, but I guess it's good to repeat them. Going to go back to 508. Going to go add consumer. I'm going to add my new contract. Oops, I need to copy the address. So let's go here, copy fortune teller. Okay, we're going to add this as a consumer. Again, that's because we just deployed a new version of this. So now we need to add it as a consumer so that it will actually work and give us a random number. And I guess this is a good proof that you can have multiple smart contracts kind of using the same subscription, right? They're just going to be drawing from the same Chainlink balance, which you provided to this subscription. Okay, so hopefully this should wrap up shortly. Okay, it looks like that is done. Now, if we go back to Remix, hopefully, if we call request random words, yes, we don't get an error this time. Okay, let's go confirm. And now, let's go last request ID. Okay, it's going to take a second. Okay, it's updated, so let's copy this. Paste this here. Notice it is not fulfilled yet. But if I continue to call it a few times, eventually it will say that it's fulfilled. And then once it is fulfilled, then we should be able to generate a fortune and then get that fortune from our fortune seeker. Okay, so this has been fulfilled now. Very good. So now we can go get fortune. Okay, so let's get our fortune. And now that we've done that, our fortune seeker should be able to get our fortune. So let's see if this actually works by just calling fortune. Okay, so we haven't gotten any fortune quite yet, and that is because we've not yet set up our upkeep. So let's take our contract address. Let's go to upkeep here and paste this in. Okay, it's unable to verify. That's fine. We're going to click next. And upkeep name, we're just going to call this Fortune Seeker. And then you have a few different options here. Okay, you have your gas limit, your starting link balance. For now, I'm just going to give this to link. And then the maximum amount of gas. Now, at this point, 500,000 is fine. I don't think we need to change this. This is going to be, as it says here, the amount of gas to provide the target contract when performing the upkeep. We shouldn't need more than this, but if for some reason it's not working, then we would change this and bump this value up. Now, as it says here, deposit link to your upkeep, select an amount that will satisfy multiple performances to start, then fund the upkeep directly once it's operational. So just like our subscription, we need to be giving this fund so that it's actually able to, well, perform the operations, right, and pay for all of the gas and fees, etc. Okay, so we don't need to fill in any of this. I'm just going to register this upkeep. All right, really the important thing is to make sure that your contract address is correct. Okay, let's submit that. We're going to wait for this to finish. And then essentially what should happen is once we fund our smart contract, our Fortune Seeker, then it should just continually be calling this check upkeep function. And then it should actually, well, call the upkeep function, right? Okay, so here we are. We can kind of see when it calls this, it'll give us some information, has the minimum balance, all of this kind of stuff. All right, so now we're going to go back to Remix. Again, I apologize for all the steps here, but it's just what's necessary in a complex project. And we're going to go and we're going to send money to our Fortune Seeker. So for Fortune Seeker, we're just going to specify here Ether. Now we need to have more than one Ether. So I'm going to send one Ether and then I'm going to send another transaction with some more because I'm running out of Ether in my account here. I only have 1.64 as it says there. So let's send one Ether. The way I can do that is just by hitting transact when that's filled in. Okay, notice that I'm sending one full Ether or AVX or however you call this, AVX. Okay, done that. Now I'm going to change this to Finny. I'm just going to send one Finny so that now we go over one Ether. And again, I hit transact. Okay, let's call this. There we go. So we are now over one Ether. Now let's go here to Fortune Seeker and let's refresh. And let's see if it's actually ran any calls here, okay? All right, so I apologize for the abrupt cut here, but over the past few minutes, I was kind of testing these contracts and realized I made a mistake. So the mistake is that I spelt Seek Fortune incorrectly in my Fortune Teller contract. So what I'm going to do here is I'm just going to take my balance out of both of these contracts by withdrawing it. So I'm going to go here to Fortune Seeker and I'm going to withdraw my balance just to get all of my Ether back. Then what I'm going to do is I'm going to fix this mistake and I'm going to redeploy the contracts, set up the VRF again, and then set up my Fortune Seeker contract. So I apologize that we're going to have to kind of redo this process here, but it's just because I spelled this wrong. So now I need to redeploy the contract, kind of just a part of doing the Web3 development here. So what I'm going to do is spell this correctly now. So this is going to be Seek Fortune, okay? And now that this function is spelled correctly, our Fortune Seeker contract should work properly because it was trying to call Seek Fortune, and this function did not work on the Fortune Teller contract. Again, apologize for the abrupt cut, but I kind of just need to fix this mistake. So now that I've withdrawn my balance out of these contracts, what I'm going to need to do is redeploy them and then reset up my VRF subscription as well as my upkeep. So what I'm actually going to do is I'm going to cancel this upkeep right now, because we no longer need this, and we'll automatically be refunded our Chainlink balance. Then I'm going to go to VRF here, and what I'll need to do is just add another consumer. This consumer will be the new contract that we deploy. Okay, so actually for VRF, first thing I need to do is just grab this VRF coordinator address, because I'm going to need that when I deploy. I'm going to go back to Remix here, and now I'm going to have to compile my Fortune Seeker and my Fortune Teller. So let's go to compile here. Going to recompile Fortune Teller. Okay, let's go to Fortune Seeker. Let's compile that. Okay, give that a second to run here. Going to go back to Fortune Teller, and now I'm going to deploy this. So I'm connected to Injected Provider. I want to be deploying my Fortune Teller. When I do this, I need the subscription ID of 508 and the VRF coordinator. So let's now transact that and deploy this. All right, so now it looks like that has been deployed. So let's pop this open. I'm going to copy this, the address here, and then we're going to go back to our VRF. We're going to go to our subscription of 508, and we're going to add a consumer, and we're going to add this consumer address. Okay, so let's do the transaction here. We can kind of wait for that to finish. While we do that, we'll go back to Remix. Again, we'll make sure we copy our fortune teller address, and then we're going to deploy our fortune seeker another time. So let me click on fortune seeker, go here, fortune seeker. My fortune teller address is this, and my update interval, again, can be 15 seconds. Okay, so let's transact this and get that deployed. Okay, let's go back to VRF. Looks like our consumer has been added. That is all good. Now we need to go back to our fortune seeker upkeep here, and we need to create a new upkeep. So I'm going to go back to home. I'm going to register a new upkeep. This is going to be based on custom logic. And then for the contract address, that is going to be the address of our fortune seeker, which is right here. So let me copy that and paste that in. Okay, we're going to go next. And upkeep name, fortune seeker. Okay, if we can spell that correctly. Gas limit, we can leave that as it is. Starting balance, let's make this to link. And that's fine for now. Okay, so let's do this transaction. Okay, very good. All right. Now that we have done that, what we need to do is kind of repeat again the process where we generate a fortune, and then we actually make sure that we fund the fortune seeker contract so it's able to call fortune teller. So let's go to fortune teller. Let's request some random words. Okay, so go ahead and request that. Now that we've done that, let's see what our last request ID is. Okay, we're going to copy that. Go to get request. It is not yet fulfilled, so let's give it a few seconds here and wait for that to be fulfilled. Okay, it should be coming any second here. All right. And there we go. It is now fulfilled. So now that it is fulfilled, we can get a fortune. So let's call this to get a random fortune. Okay. Let's give that a second to finish here. Okay, that's done. Let's now go to last returned fortune. And there we go. We have a fortune. Now that we have that, let's go to our fortune seeker. Okay, now that we're at fortune seeker, what we want to do is fund this. So the way I can fund this is I can go here and I can enter 1 ether. All right, and then I'm just going to hit transact. And I'm going to send this 1 ether, and I'm going to have to send it a little bit more just so that we go above 1 ether as the contract balance, and that way we are able to call seek fortune. Okay, so let's send this a little bit more. Again, I can just go here and send this 1 finne. All right, let's transact and send this through. Okay, again, we'll give that a second to go through. All right, very good. So now that it's gone through, let's just check some of these variables. So interval, last seen timestamp, okay, owner. And now what should be happening is we should actually automatically be calling seek fortune, which should then send the funds to our fortune teller and then retrieve the fortune. Since our fortune teller already has a fortune, we should be getting one in this contract. So let's have a look at our upkeep here. Okay, so let's view the upkeep, and we can see that we have a balance, and it says the last date ran was December 4th, 2022 at 15:21. What that means is that it did actually run our function for us to seek the fortune. So since it did that, if we go back here and now we look at our fortune, we see that we have a fortune. Now notice on fortune seeker, I haven't ran any of these functions myself. This was the upkeep that ran the seek fortune function. So it called check upkeep. Since that returned true, it called seek fortune, and it automatically updated the fortune for us. Again, notice I've not manually called any of those functions, and our balance has now decreased. So now we need to fund this again, otherwise it's not going to allow us to call this. So let's send even more. In terms of finne, we can send this, I don't know, let's go 100 finne. I don't know how much that actually is, but let's transact that here. Okay, let's pass that in. Give that a second. And let's see here. Now we have slightly more balance. Okay, so that's good. Now what I want to do is go to fortune teller, and I want to change the fortune. So I'm going to request more random words, and I'm going to show you that the fortune will automatically update. So recall our fortune is a golden egg of opportunity falls into your lap this month. Okay, that's what it was before. Now we're going to go to get fortune. Actually, let's just make sure this request is good first. So let's copy this, go here. It's not fulfilled yet. Okay, so let's wait for that to be fulfilled. And then once it is fulfilled, we'll generate a new fortune. Then we'll go back to the fortune seeker and we'll see if it has that updated fortune. Okay, so it's been fulfilled now. Let's go to get fortune. Let's go here. Okay, very good. Let's wait for that to go through. Okay, that's gone through. Now let's go to last return fortune. Notice we have a new one. You will learn patience from smart contracts, okay? Now let's go back to fortune seeker. And again, notice I haven't called any of these functions. And let's see what our fortune is. And notice it automatically updated here. You will learn patience from smart contracts. There you go, and you'll see that this balance will continue to decrease so long as the condition is met. So every 15 seconds, essentially, this is going to be called, and it's going to update the fortune anytime we change this in Fortune Teller. You can see that this actually just dropped by 1. Okay, there you go. We have just set up our automation. We now have this working with our random numbers, and really at this point, we have completed the project. I know that there was quite a bit of stuff going on here and a little bit of confusion at the end because we had a spelling mistake and there was all kinds of things that I needed to fix. Again, unfortunately, that's just a part of doing smart contract development. There is going to be mistakes like this, and hopefully kind of watching through this, you can see how I persevere through those and fix those mistakes, go back, redo the process, etc. That's just what happens whenever you're writing any kind of code. So with that said, that's really going to start wrapping up the video here. So at this point, you've seen, again, how to set up automation to automatically be calling a smart contract, which is what we just did. Again, you can see that from this page right here, our automation page. We also looked at how we used VRF, so our verifiable random function, to generate random fortunes within our smart contract. We then saw how we could kind of use both of these in a combination where our fortune seeker is constantly getting any of the updated fortunes from our fortune teller. Now, if you wanted to go a step further, you could actually automate the fortune teller contract such that it is automatically going to generate a new random number every 15 seconds or minute or hour or whatever time frame you want. That way, you might have 2 sets of automation where the fortune teller is being automated and then the fortune seeker is automatically getting any of the new updated fortunes from fortune teller. Really, the point of this project was to give you an in-depth example that used multiple smart contracts with different Chainlink functionality so you can kind of see how it works and how to set it up. There is quite a bit of setup. There's a lot of stuff that you need to do, but once you understand that, it shows you really the power of smart contracts and what you are able to do on the blockchain. Obviously, this is just a small example. You can extend this and make it much more in-depth. You can make much larger projects with this technology, and we hope that you're going to do that in the future. So let me just quickly go back here to our main code. I will mention here that there is automated tests if you'd like to run that on your code. Now, these tests may fail simply because some of them are checking a specific error message. So it may say something like, it didn't revert with the correct error message because you typed it incorrectly or you didn't use the right capitalization. If that's the case, you can go in and modify the test, or you can modify your actual code. I'm not going to show you kind of how we go through this. We've already looked at it. If you want to run it, you can do npx hard hat test, and feel free to kind of study through the test here to see how this is written to interact with Chainlink. Again, that's a bit beyond the scope of this video. So with all of that said, all of this code will be available from the link in the description. I hope that you found this video valuable, and I look forward to seeing you in another Blockchain Expert video.